We encounter parabolas everywhere, from the arc of a basketball throw to the shape of a satellite dish. These elegant curves, mathematically represented by quadratic equations, hold the key to understanding various phenomena in our world. Unraveling the mysteries of the quadratic formula empowers us to solve real-life problems across diverse fields, from physics and engineering to economics and beyond. It's a mathematical tool that's as versatile as it is powerful, and its applications are virtually limitless. The quadratic formula might seem intimidating at first glance, but fear not. It's simply a roadmap that guides us to find the solutions, also known as roots, of any quadratic equation. These roots represent the points where the parabola intersects the x-axis, providing crucial insights into the behavior of the system being modeled. Whether you're trying to determine the optimal price for a product or calculate the trajectory of a rocket, the quadratic formula is an indispensable tool. The beauty of the quadratic formula lies in its ability to handle any quadratic equation, no matter how complex. It's a universal key that unlocks a treasure trove of solutions, allowing us to make sense of the world around us with greater clarity and precision. So, let's embark on a journey to demystify this powerful mathematical tool and explore its remarkable applications in our daily lives. Every quadratic equation follows a standard format. Ax2 plus bx plus c equals sine 0, where a, b and c represent known constants, and x is the unknown variable we aim to find. The quadratic formula provides a clear, concise method to solve for x. It's like a mathematical recipe, guiding us through each step to arrive at the solution. The formula itself is surprisingly elegant. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. While it may seem daunting at first, breaking it down reveals its simplicity. The expression under the square root b squared minus 4ac is called the discriminant. The discriminant determines the nature of the roots. To use the formula, we first identify the values of a, b, and c from our quadratic equation. We then substitute these values into the formula and simplify the expression step by step. The plus-minus symbol indicates that there are two possible solutions, one obtained by adding the square root term and the other by subtracting it. These two solutions correspond to the points where the parabola representing the equation intersects the x-axis. Mastering the quadratic formula is like acquiring a new superpower. It empowers us to solve a wide range of problems that would otherwise seem intractable. With a bit of practice, you'll be surprised how easily you can navigate the world of quadratic equations and unlock their hidden potential. Let's move beyond the theoretical and delve into the practical applications of the quadratic formula. Imagine you're a physicist studying the motion of a projectile like a baseball soaring through the air. The quadratic formula helps you predict the projectile's trajectory, its maximum height, and the time it takes to hit the ground. Now let's shift gears to the business world. Imagine you're an entrepreneur trying to maximize your company's profits. You can use quadratic equations to model your costs, revenue, and ultimately your profit margin. By finding the vertex of the parabola representing your profit function, you can pinpoint the optimal price point to maximize your earnings. These are just a few examples of how the quadratic formula finds practical use in diverse scenarios. Whether you're designing bridges, analyzing financial markets, or programming video games, understanding quadratic equations equips you with a powerful tool to model and solve real-world challenges. The ability to predict, optimize, and understand complex systems is a valuable asset in countless professions. Section 4. Conquering complexity applying the quadratic formula to electronics. The realm of electronics might seem a far cry from parabolas and equations, but even here the quadratic formula plays a crucial role. Electrical engineers rely on it to design circuits, analyze signals, and optimize the performance of electronic devices. For instance, the behavior of resistors, capacitors, and inductors in AC circuits can be effectively modeled using quadratic equations. Consider the design of filters used in audio equipment or telecommunication systems. These filters, essential for separating desired frequencies from unwanted noise, rely on principles rooted in quadratic equations. The quadratic formula helps engineers determine the optimal values of components to achieve the desired filtering characteristics. The quadratic formula's significance in electronics highlights its versatility as a problem-solving tool. It seamlessly bridges the gap between abstract mathematical concepts and practical applications, demonstrating its relevance in our increasingly technology-driven world. Whether you're designing the next generation of smartphones or building sophisticated medical equipment, understanding quadratic equations provides a solid foundation. Section 5, Quadratic Mastery, your gateway to STEM success. Mastering the quadratic formula is not merely about memorizing a formula, it's about developing critical thinking skills, enhancing problem-solving abilities, and building a strong foundation in algebra. These skills are essential not only for excelling in STEM fields like engineering, physics, and computer science, but also for thriving in our increasingly complex world. Understanding quadratic equations opens doors to a wide range of academic and professional pursuits. It equips you with the tools to analyze data, model real-world phenomena, and make informed decisions based on logical reasoning and mathematical principles. The ability to think critically and solve problems using analytical approaches is highly valued in today's job market. As you delve deeper into the world of mathematics, you'll encounter even more advanced concepts that build upon the foundation laid by the quadratic formula. Calculus, differential equations, and linear algebra, all essential tools in STEM fields, become more accessible and comprehensible once you've grasped the fundamentals of quadratic equations. Embracing the challenge of mastering this formula paves the way for a lifetime of learning and discovery. Section 6, Beyond the Equation, the enduring relevance of quadratic skills. In an age dominated by computers and sophisticated software, one might wonder about the continued relevance of mastering seemingly abstract concepts like the quadratic formula. While it's true that computers can now solve complex equations in a fraction of a second, it's the human mind that programs these computers, interprets the results, and applies them to real-world situations. Understanding the underlying principles behind the equations is crucial for interpreting results accurately and making informed decisions. Blindly relying on software without a solid grasp of the underlying mathematics can lead to misinterpretations, inaccurate predictions, and potentially costly errors. The quadratic formula serves as a reminder that true understanding stems from a deep comprehension of fundamental principles. Moreover, the process of learning and mastering the quadratic formula cultivates valuable cognitive skills that extend far beyond mathematics. It nurtures critical thinking, problem-solving abilities, logical reasoning, and abstract thinking, skills that are transferable to any field or endeavor. In essence, the journey of conquering the quadratic formula is as valuable as the destination itself, shaping us into more capable and adaptable learners.